Now we want to talk about the plus or minusness of the 6 trig functions depending on which quadrant you're in. So just for review, the first quadrant is here, the second quadrant here, this is the third, and the fourth is over here, and that's just the way you'd get them if you're rotating a ray around here through 0 to 360 degrees. Now, it's important, first of all, just to remember this little trick that on a unit circle, if that radius is 1, then the x-coordinate is always the cosine of theta, and the y-coordinate is always the sine of theta. Now that tells us a lot, because we already know about the pair xy. The pair xy is going to, both the x-coordinate and the y-coordinate are going to be positive up here in the first quadrant. Once you rotate over here, well, now we've moved to the left of the origin, but we're still above the origin, so the x-coordinates are negative, the y-coordinates are positive. Once you get around down here, both x and y were to the left and down from the origin, so this is the minus quadrant. And over here, the x-coordinates are back positive again. We're to the right of the origin, but we're still below it, so the y-coordinates are negative. Now that tells me about the sine and the cosine automatically. In here, both the sine theta is positive, and cosine theta is positive because both x, cosine, and y, sine, are positive. Over here, the sine of theta, that's the y-coordinate, that's still positive, but the cosine of theta, the x-coordinate, is negative because now I've got rays over in this direction that are pointing to the left of the origin. By the time the ray gets down around into the third quadrant, then it's both to the left and down, so we know that the sine of theta is negative, and the cosine of theta is negative. And finally, over here in the fourth quadrant, we have the sine theta, that's y-coordinate, is negative, and cosine theta, the x-coordinate, is positive. Now, notice I'm just remembering that this is the x-coordinate, and sine of theta is the y-coordinate on the unit circle. So I don't really have to memorize this picture. I'm able to produce it whenever I need it, and I can do it very, very quickly. Now you might say, okay, now I got 4 more trig functions, I got to memorize all of that. No, you don't. The tangent theta, remember, is the sine of theta over the cosine of theta. So whenever the sine and the cosine have the same sign, both positive, or if both the sine and the cosine are negative, that would be a negative over a negative, then that, both here and here, the tangent is going to be positive. Here, in the second quadrant, and over here, in the fourth quadrant, the tangent will be negative because the sine and the cosine have opposite signs. So plus divided by minus or minus divided by plus, either way, you're going to get a negative ratio. So negatives here, positives here. Cotangent, well, it's going to follow the tangent because it is simply the reciprocal of the tangent. And if, say, you take a positive number, 1/2 takes its reciprocal, you get 2. The reciprocal of a positive is positive, the reciprocal of a negative is negative. So cotangent always follows the tangent as far as whether it's plus or minus. And then the secant is the reciprocal of the cosine. So if the cosine is positive, the secant will be positive. And if the cosine is negative, the secant also will be negative. And finally, there's the cosecant. Well, the cosecant is the reciprocal of the sine. So if the sine is positive, so is the cosecant. And if the sine is negative, so is the cosecant. So I don't think that just raw memory is the best way to approach this pattern. You remember that the x-coordinate is cosine, the y-coordinate is sine, and then you'll know just from the picture whether each one of those is plus or minus. For anything else, you can figure it out. Now, I can just imagine someone saying, for anything else, you can figure it out. What on earth does that mean? I think I'm just going to have to memorize or keep a chart around. No, you won't, actually. Take a look at this one. We know that the sine of theta is positive and the tangent of theta is negative. Which quadrant are we in? Well, the sine is positive. That's the y-coordinate. So that means we're either here or here, right? Now, the tangent is negative, which means that this is sine over cosine. So that means sine and cosine have opposite signs. If sine is positive, then cosine must be negative. We have to be in this quadrant, not in this quadrant. So the answer is that we are in quadrant 2. And if you think about that, if you have the cosine of theta, sine of theta, if this is negative and this is positive, then you get exactly this pattern. The sine, on the other hand, is positive, so we match this pattern here being in quadrant 2. If the tangent is negative and the cosecant is positive, which quadrant are we in? Well, remember, the cosecant is nothing other than 1 over the sine. So if the sine is positive, so is its reciprocal, and vice versa. So we know that the sine of theta must be positive. Now, the sine is the y-coordinate, so that means we're on the top half of the picture. What about the tangent? Well, the tangent is the sine over the cosine. So if the tangent is negative when the sine is positive, that means the only way to get that is to have a cosine that's also negative. And once again, we've landed here in this quadrant. Let's see if we can find one that's a little bit different. What if we knew that both the tangent were positive, but the cosecant were negative? What would that mean? Well, a cosecant, that's related to the sine. It's the reciprocal of the sine. So if the sine is negative, the cosecant is negative, and vice versa. So that means the sine of theta is negative. That's the y-coordinate, and therefore we're either down here or here. The tangent, on the other hand, is positive. Well, the tangent is sine over cosine. If the sine is negative, you'd need a negative cosine in order to get this ratio to come out positive, right? If you have a negative over a negative, that's positive. So that tells us both tangent is positive, cosecant is negative. That means the cosine itself must be negative. The cosine is the x-coordinate. That's negative. So we've got to be here or here. The sine is negative. That's the y-coordinate. We've got to be either here or here. So it lands us right there in the second quadrant. So that's how you can solve these kind of problems. If you know the whether two functions are positive or negative, as long as one is not just a reciprocal of the other, like the cosecant or the sine, then you're able to determine which quadrant the angle must be in.